Now that you know a bit about our modern atomic model, let's see how we can use the periodic table of elements to learn even more about the structures of specific types of atoms. Carbon is a really important atom on Earth, especially in living systems. It can be found right here on the periodic table, and if we zoom in on its box on the table, we can find out a lot more about it. The first number you see sitting on top right here is carbon's atomic number, 6. Each element on the periodic table has a unique atomic number. This number tells us the number of protons in the atom's nucleus. These two numbers will always be equal. So, if an atom has 6 protons, you know for sure that you're looking at an atom of carbon. Assuming that the atom is uncharged, the number of electrons orbiting its nucleus should be equal to the number of protons in its nucleus. This really makes sense if you think about it. 6 positive charges in the nucleus have to be balanced by 6 negative charges, which come from the electrons. The next number you'll notice in carbon's box is the decimal sitting below its chemical symbol, 12.01. This represents the atomic weight of carbon, or how heavy it is. Atoms are tiny, of course, so we have to use really small units called atomic mass units to measure this. The atomic weight listed on the periodic table is actually a weighted average of all of carbon's isotopes, but we'll get more into that later. For now, remember that if you round the atomic weight to the nearest whole number, you get a new important number for carbon, and that's the atom's mass number. For carbon, the mass number is 12.01, rounded to 12. Now, most of an atom's mass is located in its nucleus, where the heavy protons and the heavy neutrons are located. Electrons are tiny in comparison. So the mass number is equal to the number of protons plus the number of neutrons. You can use simple algebra to conclude that carbon has 6 neutrons in its nucleus, since we already know that it has 6 protons. You might notice that carbon has the same number of protons as it does neutrons. That happens sometimes, but it's not always the case. Here are some examples for you to try on your own. For each of these two given elements, aluminum and sulfur, try to figure out the number of protons, neutrons, and electrons in an atom. Once you're done with those two, try to choose your own atom from the periodic table, any one you like, and find the number of protons, neutrons, and electrons. Pause the video at this point, try these practice problems, and then play the video to reveal the answers. Hopefully you got both of these correct, and we'll go over your number 3s at our next class.